Today, we'll delve into organizing your sequence data for optimal analysis and processing. This is essential when dealing with data sets comprising a series of events, such as in healthcare, sports, e-commerce, and sensor data applications. Let's begin by understanding the importance of structuring your data into an entity table and a linked events table. Imagine you have a data set detailing baseball players and their statistics across different seasons. This is a sequential data set where the timing and sequence of events, here, the seasons, offer valuable insights. Our goal is to split this data set into two, one focusing on the entities, in our case the baseball players, and the other on the events, the seasons and their statistics. First, identify the static information in your data set. This includes details that describe the entity and do not change over time, such as a player's name or ID. This data will form your entity table. Each row in this table represents a unique individual and must have a unique entity ID, which serves as the primary key. The rows are independent of each other and contain only static information. Next, create your linked table, which will house the dynamic, time-ordered information related to the events. In our example, this could be the player's statistics for each season. Each row in this linked table should correspond to a unique event and must include a foreign key that links back to the entity table's primary key. This setup allows multiple rows in the linked table to correspond to the same individual, reflecting the chronological sequence of events. Here's a concise guide to organizing your data effectively. Entity table requirements. 1. Each row represents a unique entity, ensuring a one-to-one correspondence with real-world individuals or items. 2. Employ a unique entity ID, primary key, for each row to differentiate entities clearly. 3. Ensure rows are independent, with each containing information that stands alone. 4. Include only static, unchanging information about the entities. Linked table requirements. 1. Allow multiple rows to correspond to a single entity, accommodating various events or states for that entity. 2. Use a foreign key in each row to link back to the entity table's primary key, maintaining a connection between events and entities. 3. Rows can be interrelated, reflecting the sequence or relationship between events. 4. Focus on dynamic, changeable information, ideally in a time-ordered sequence to track changes or trends. Inspect your events or linked table for any static information that describes the entity rather than the event. This data should be moved to the entity table. Let's consider our baseball data set. The players table serves as the entity table, including static information like player names and IDs. The seasons table, or our linked table, records the dynamic, time-ordered statistics for each player across different seasons. Here, it's crucial that the seasons table links back to the players table via a foreign key, ensuring a relational structure that accurately represents the sequence of events. By meticulously organizing your data into entity and linked tables, you lay a strong foundation for data generation job. Whether you're tracking patient journeys, analyzing sports statistics, monitoring sensor data, or studying consumer behavior, this method enhances the clarity and usability of your data. Thank you for watching, and we will see you in the next episodes.